Hey everyone, welcome back to Tech Adventure. We will continue our journey into the field of embedded and software development skills. Today, we're exploring Software Development Lifecycle, SDLC, your roadmap to building software. We'll cover everything from its concepts to best practices. Whether you're a newbie or a pro, join us as we unravel the world of SDLC. Throughout this adventure, we'll break down SDLC into bite-sized pieces, covering everything from how it works to the different methods you can use to implement it. If you missed our previous video covering the essential skills required for embedded developers, I highly recommend checking it out first. Get ready to dive deep into the world of SDLC, where we'll demystify its concepts, explore its methodologies like Agile, Model, and Waterfall, and uncover the best practices that will set you on the path to success in your software development endeavors. Let's dive in. The Software Development Lifecycle, or SDLC for short, is like a roadmap that guides software development projects from conception to delivery. It's a systematic approach that helps teams plan, build, test, and deploy software solutions efficiently. The software development lifecycle consists of several models or methodologies that guide the process of developing software. The software development lifecycle comprises requirement gathering, design, development, test, deployment, and maintenance. Each software development stage is handled by a dedicated team of professionals with expertise in the niche. SDLC stages mostly stay constant no matter what software development methodology we follow. However, the approach towards implementing these stages changes with changing development methodology. Let's explore the steps of the Software Development Lifecycle, SDLC. Understanding each step will help us better comprehend different methodologies used in software development. 1. Planning or analysis or requirement gathering. In this step, the client defines a problem that needs to be solved, which further forms the basis for finalizing the requirements. We gather all the information from the client and users, if required, to create requirement documents so that the development team understands what they are building. Then follows planning, which includes distributing work across teams, setting milestones, creating timelines for delivery, getting cost estimates, conducting a risk analysis, and devising a plan to mitigate the risks. Creating a proof of concept is also part of this stage, where the technical feasibility is checked and validated before proceeding with the development work. 2. Design. The design phase of the software development lifecycle focuses on creating software architecture, system design, prototypes, and user experience design. Software architecture refers to creating an organized flow of elements in a software code for quality assurance, clarity, and accessibility. You can refer to software architecture as the blueprint for the development team. The UI and UX team builds a prototype version of the software to validate its look and flow of design elements. It lets the development team and the stakeholders visualize the overall look and feel of the software. 3. Development. In this SDLC phase, coders work on bringing the concept into reality. The developers create thousands of lines of code using programming languages which suitable for the project and the team comfortable with. The development team might release the software in one go, as with waterfall development, or can choose to deliver software in fragments, segmented into features, using Agile development. Once the code is ready, the development team reviews the code and shares it with further process. 4. Testing and quality assurance. This stage of the development lifecycle phase focuses on testing the written code for bugs and other inconsistencies. The testing and quality assurance team works to test and report the bugs to the development team. The testing team can rely on manual or automated testing for their expertise and defined process. We can say that the testers and the development team work together to ensure foolproof software delivery. 5. Deployment. The entire software or a part of it goes into the production environment phase after developing, testing, fixing, retesting, and validating. If you follow the Agile SDLC process, deployment could be one part of the features. However, in the case of Waterfall, deployment refers to launching a fully fledged product in the market. If the end users experience any issue with the software, it moves back to the software development team for reconsideration and fixing. 6. Maintenance. New requirements will likely drop with new technologies and changing user requirements. The software development team needs to iterate through the entire software development lifecycle to accommodate these requirements to work on the recent change. Thus, maintenance implies that software requires updates from time to time, which you must frequently do to uphold the software's value proposition. The common types of maintenance include corrective maintenance, removing the existing bugs from the software to improve its performance. These errors come to light, generally through user reviews. Perfective maintenance. New requirements keep evolving from time to time. And, to stay relevant and valuable, the software needs to be updated to accommodate these changes. That is the idea behind perfective maintenance. I hope you've grasped the essence of the various phases within the SDLC. We'll delve deeper into each phase in upcoming videos. But first, let's explore the popular methodologies or models used in software development. Some of the most common software lifecycle models include 1. Waterfall Model. Waterfall Model, also called the linear sequential model, Waterfall is the most traditional software development process. The term Waterfall Model is used to describe this method of software development due to its structure. The model is characterized by a sequence of phases, where each phase depends on the deliverables of the previous one and corresponds to a specialization of tasks. This progression is similar to a waterfall cascading downwards, hence the name given. Here is how the software development process flows in the waterfall approach: planning, requirements, system and software design, implementation, testing, deployment, maintenance or updates. Since the waterfall approach involves a lot of planning and documentation, it is easy for the development team to understand and use it. However, the waterfall process is expensive, and changes often take time. The approach also involves risks as changes are costly. If you're enjoying the video, please consider giving it a thumbs up and subscribing to our channel. We value your input, so feel free to share your suggestions for topics you'd like to see covered in the comments section below. 2. Agile Model and Scrum. Agile is an iterative and incremental approach to software development that emphasizes flexibility, collaboration, and customer feedback. It focuses on delivering working software in short, iterative cycles known as sprints. The Agile model typically involves the key practices like iterative development, continuous integration, test-driven development, customer collaboration. Scrum is a type of Agile framework. It's a framework within which people can address complex, adaptive problems while productivity and creativity of delivering the product are at the highest possible values. Key features of Scrum include sprint, release, sprint review, sprint retrospective, product backlog, and sprint backlog. You can go through each one if you're looking for more info. The Agile approach moves fast, releases often, and caters to user needs instead of following a rigid documented procedure. Therefore, it becomes easy to incorporate user feedback throughout the development process. The Agile software development process is the best if you have a dynamic team working on a project that requires continuous updates. However, you should avoid it if you have a resource-strapped team with a tight budget and a strict timeline. 3. V-Model. V-shaped planning is an enhanced take on the classic waterfall process that aims to reduce its biggest downfall, the lack of testing. It emphasizes testing at each stage of development. It aligns testing activities with corresponding development phases, forming a V-shape. The approach is simple. Instead of following all the steps in sequential order and saving testing for the end, we follow strict validation and verification at the end of each stage. This way, we aim for total quality management in software development. V-shaped planning is best if your team works on a small product with precise requirements. However, if you want flexibility and early input from users, or the conditions are unclear, V-shaped planning is not for you. It will be challenging to lay out a clear plan without precise requirements. 4. Incremental Model. The incremental software development process is a middle ground between traditional waterfall and agile approaches. Here, we develop software in small parts and test each piece individually with users for feedback. Each increment in the incremental development process adds a new feature. Here is how the process flows in the incremental software development process. Specifications, development, validation. Incremental software development is less expensive. Also, it is easy to incorporate sudden changes. However, the process can be time-consuming and requires a lot of planning. The incremental software development process best suits teams with precise project requirements and more flexibility. However, teams with a clear long-term technology plan should avoid this approach. Now that we've explored these different SDLC methods, you might be wondering, why do we need them? The Software Development Lifecycle, SDLC, is essential for several reasons. 1. Provides structured approach. 2. Helps risk management. 3. Provide quality assurance. 4. Provide predictability. 5. Helps communication and collaboration. 6. Provide customer satisfaction. 7. Provide continuous improvement. Overall, SDLC provides a systematic approach to software development that improves efficiency, reduces risks, enhances quality, and ultimately leads to successful software projects that meet both business and user needs. Deciding which software development lifecycle model to use for a project involves considering several factors, including project requirements, team capabilities, organizational preferences, and external constraints. Here are steps to help you make an informed decision. 1. Understand project requirements. 2. Assess organizational factors. 3. Analyze team capabilities. 4. Consider project constraints. 5. Evaluate risk factors. 6. Explore stakeholder expectations. 7. Select the most appropriate model. 8. Monitor and adapt. By following these steps and considering these factors, you can make an informed decision about which SDLC model to use for your project, ultimately increasing the likelihood of project success and delivering value to stakeholders. To sum up, SDLC serves as a blueprint for software development projects, guiding teams through the entire development lifecycle. By adopting best practices, embracing collaboration, and staying agile, teams can overcome challenges and achieve their project objectives. Thanks for watching, and until next time, happy learnings!